Welcome to MarinEngBase. So today we're gonna discuss about referring electrical drawings. What I feel in the industry, most of young engineers are facing some difficulties regarding referring electrical drawings. So if some fault occur in some specific machinery, so they are struggle to find, or they will consume much more time, not only because that lack of mechanical knowledge. Maybe they are well competent with the mechanical knowledge, but there are some lag in areas of this referring electrical drawings. So today we will clarify what are the things, important areas in electrical drawings, how we can refer, we can swap between electrical drawings and also PLC connection, and then with a mechanical or hydraulic and drawings. Basically, as a start, I would like to give a small introduction about this drawing. This is a electrical system drawing of a crane. Uh, in electrical drawing, it's very important to give a data reference point. So in this drawing, we can see this number 1, 2, 3, 4, 5, 6. These are the column numbers. And here you can see the row numbers. So if you want to give some component, there are many components in this diagram. Don't worry. Usually an electrical drawing, it's coming with a bulk. That means it has many pages. So it is Ola or almost maybe it's combined to another page. So in a manual, these electrical drawings are given in a separate set. So in this set, usually in first pages, they are giving all the symbols, which symbol is related to which. So don't mess up with your, don't you don't want to keep it in mind, but general idea, you should have a basic idea of these symbols. So what we were discussing was, mm, if you want to locate any component in this diagram, so then there should be a coordinate. So then you can mention this mm, component as fifth column in row B, fifth column in row B. So it is this purpose of this coordinate giving, or this dividing this into horizontal and vertical, is to giving the, or to locate the components. Mm, Now we will move to one by one items. So then we can have some rough idea about this diagram of the components. Mm, There are four motors. These are electrical motors which are connected to a bus bar. This is a bus bar, main voltage here 440 volts. And these motors are operating via some contactors. As a switch in our normal illumination or lighting system in your home appliances, to deal with large currents and have more accuracy, they are using electrical contactors. So these are kind of electrical contactors. There are three motors and electrical contactors. And also there are some uh, protection devices. These are safety devices provided in case of overcurrent or under voltage or voltage. So these are the arrangement. Mm, Now we'll see what are these things. This, if you see some X2 or this kind of nomination, so it means a terminal block. This is X2. That means if you open the electrical cabinet of this relevant appliance, then you can see this number. And also there are terminal or that number, we call it 11, 12, 13. X2 is the whole block. The block is usually is appear like in this figure. So this is a contact block. The wires are connecting here, and also you can tight all those with the screws. Then if you see carefully, this is, this is a symbol of contact. There are three open contacts and one outside another contact. These contacts are numbered with 1, 3, 5. 1, 2, 3, 4, 5, 6. Okay, let's so 1, 2, 3, 4, 5, 6. And here you can see another 13 and 14. So there are two different groups of contacts shown here. That means we call it main and auxiliary contacts. This whole thing, you can say the real arrangement this way. These are the main contact. That means L1, L2, and L3. This small block which is mounted on these main contacts are the auxiliary contacts. Auxiliary contacts, they have normal open, normal close, and here also normal open contacts. You can use these contacts in your control circuit to get done some other operation which is aligned with or simultaneously operate with the main contacts. So main and auxiliary contacts are there. And this one is the main activating relay, or more or less we can say it's the main contactor. So it is K11, its notation is K11. And if you switch on this breaker manually and no any overcurrent relay is activated and your bus bar is alive, then once you switch on this one, then the motor should run. And this is a main contactor. So let's see how normal appearance of a contactor. So this is the contactor. This contactor, it has this blue color thing that is the operating mechanism, that which means that if you want to operate it manually, then you can depress this one, then your contactor will energize. In other case, if it is working with its remote or by control system, while it changes to energized position, then this blue color thing will move inside. So it will be an indication of that this contactor has energized. That is the contactor. And then this thing here, it's a overcurrent relay device. So it's a symbol of an overcurrent relay device. Mm, it is usually a physical view of overcurrent relay with some settings is like that. Sometimes they are mounted on the main contactor. Then this motor, it's a star delta arrangement. Actually, regarding motor starters and other motor theories, we will be discussing in a separate discussion. Here I will not discuss about delta, but just to have an idea about this drawing, this is the arrangement of star delta starting arrangement. There are three contactors arranged for this star delta starting arrangement. It is for minimizing the starting current. So this is main circuit breaker, and then main contact, and then delta contact, and here will be star contact, and then a overload relay, the motor. So these are the basic information, and there are few more informations given in this diagram, especially like this. This is, I told you, this symbol is for overcurrent relay. So this is the ampere rating, current rating of that particular relay. And if you want to refer from where this contacts coming, or in this case, suppose this is main contactor. So if you want to know from where this is energized, so this is only a contactor contacts. Actually, the coil, where is the coil? Then to locate the coil, they are giving some clue here. It is 9.6A. What does it mean? Actually, number 9 means the page number. And 6A means, 6 means the uh, column number, and A means the row number. You have to go to page number 9, and then you have to search for number 6 column and A row number A. In electrical drawing, it's very much important this page number. There are 36 of total drawing, and this one is page number 4. And now we are in page number 4. If you want to tackle the K11 contactor, then you have to browse for page number 9, because it is in page number 9, 6A. Suppose if you want to mention this terminal block, So its coordinates is page number 4, that means 4.7C or 7D. Let's say it is more or less it is under D. So it will be in page number 4. So it will be 4 point how then it will refer 4 point then 7D. The notation will be like this. Uh, then now with that basics, we are going to discuss about or analyze a circuit of a air compressor. Start. The purpose of this, if you are struggling to find out some problem, suppose your air compressor is not starting, so in that case you can refer your drawings. So we'll see the sequence of these drawings, and then you can tackle why that motor is not starting. So basically this is a motor starter or a air compressor motor starting circuit power diagram. Unlike the previous one, this drawing, they don't supply row numbers, only the column numbers we can see. Okay, first thing, we should know where we stand. We are in page number 5. And as a symbol, this is the motor. So it is a compressor main motor. So if the compressor motor does not start, means it is not getting power. From where the power it receives, these are the main line. Oh, we can see there is an open contact. There is an open contact, that is 6K1. 6K1 contactor contacts. And after that, it going to the main supply, main switchboard power supply portfolio. So if your main supply is there, that means it's energized till this point. If this contactor is energized, then your compressor should run. So then this is the compressor motor and this one is main contactor. And this is, as a symbol, this is overcurrent relay. So if you want to refer 6K1 relay, so then you can come to know how this relay should energize under which sequence. So then we will move to 6K1 to find the 6K1 relay of the contact. So then you have to refer the page number 6.3. That means page number 6, number 3 column. Now we are in page number 5. Then we will move to page number 6. This is page number 6. And the column number was number 3. Then this one is 6K1. This is the main contactor controlling coil. We can see here you can get the 230 volt AC control supply. If you carefully look our previous power supply diagram, here this is the supply 220 volt, it or 230 volt. It is coming from the step down transformer from main supply, stepping down, and then you can see this supply is going to page number 5.2. Here it mentioned where it goes from. It will go to 5.2, 7.2, 8.2. Yeah, like that. Now we are in number 5 and we are going to move to number 6. You can see this is 6.2 also. Then we can move to this diagram and it is connected to page number 516 number, and this supply is, you can receive supply from here. And other thing that you can see, this supply actually coming from 7.2 diagram. 7.2. This is number 7 and 7.2. This is the place that voltage is going. But this 230 volt will not direct to that drawing. It has to pass with the 7K1 relay. This 7K1 relay. What is that 7K1 relay? How it can energize? It has a holding contact. We call it as a holding contact because this nomination and this nomination is same. So this is supply voltage A1, A2 supply contacts. And this 7K1 means it's an auxiliary contact which you can use to hold this relay. That means once energized, even though if you release that line from this line, it will maintain the supply via this line to energize this relay throughout the the power available in this main line. And now we are getting confused because you can see now we are a bit confused because here 7K1 and 5F2 something is there. We'll see what is 5F2 and 7K1. Now again back. If you want to start motor, so 6K1 should energize. Then you will come to page number 6, number 3 column. And you can see your main supply, okay, suppose it is available somehow. Then you have a selector switch here, 1, 0, 2, 3 position. 1 means hand, 0 means off, 2 means auto. If you select it to auto, then what will happen? Sorry, manual. That means this direction. If you make the contacts here, then your supply will pass via this 5F2 and 7K1 and it will reach 6K1. Then your compressor will run. And suppose if you are selected that in auto mode, then before reaching to 6K1, the supply path is moving in, it will flow in this direction and it will go to this 6B1. What is this 6B1? It is the pressure switch. And this pressure switch, that means it will monitor the air bottle pressure. And if the pressure switch gives, make this contact, then that supply will available here. And if there is no opening in these two contact, then in auto mode, your compressor will start. But what will happen if this normal close contacts remains open? What is this 5F2? If you remember, 5F2 means this one is the overcurrent relay. Suppose if your motor get overcurrent or overloaded, in that case, this relay will activate and this contact will open and it will not allow to start the compressor. And what is the 7K1? Then we have to go to 7K1 in page number 7. This one. Actually, it is activated by 5F2, the previous overcurrent relay. And this is a series arrangement of a protecting device. So in that case, once this relay activated or once your compressor get overloaded, in that case, this relay will energize and through this holding contacts, even though that overloading condition disappeared, this contact will energize this relay until that you interrupt the main supply. That means you have to go personally to local location and you have to switch off the main breaker. You have to switch off the main supply. Then only you can restart the compressor because it should be because we don't know why it is overloaded. So this is the basic. Now we just discuss. I just want to show you from where to which page that you have to refer and how you can come and go back in between drawings. Let's move to the next section. That means the PLC diagram. Okay, this is a PLC diagram. This is from a crane. So this one is PLC input module. That means if you open a crane cabinet in your PLC arrangement, this one will be the input module and it has a numbering. Then this number, they are receiving some signal from control levers, such as this is the joystick in case of what we call mm, crane. So this joystick, it has hoisting, lowering, and low speed adjusting thing. So once you activate, this signal will send to the PLC input module. So in a circuit diagram, this is the arrangement that it's showing. And the same way, if you refer the PLC output module, this is that arrangement of a PLC output. And this output will move to, it will send the signal to control something. In this case, these are Y numbering, these are all solenoid valves. And suppose if your crane operator operate his joystick to hoisting operation, then to do the hoisting, then uh, that signal will receive by input module and then PLC will process and it will send the signal to PLC output module. First, you have to release the hoisting brake. So that hoisting brake signal will release from the PLC output module. Then this valve will activate. And this is a solenoid valve. Electrohydraulic crane. This is a electrohydraulic crane. So this valve will release hydraulic oil or pressure to the brake release arrangement. If you want to know where this valve linked or how its arrangement provided, then you can refer the hydraulic diagram. So this is the hydraulic diagram, and this one is 1226. 1226. So in this is a very complex drawing that you can see, but it's a very simple arrangement. We will discuss in future day how to read these drawing, hydraulic drawings in detail, each and every component. So this is hoisting circuit, hoisting drum management. This is the brake, and to release the brake, you have to supply the oil. So in that case, to energize this valve, that electrical signal should comes from this PLC module. Okay, basically, these are the electrical circuit swapping arrangement. That means it is linked from one drawing page to other drawing page, and of course, same as it is linked to, in this case, to hydraulic drawings also. So now you have a basic idea of running between drawings and the components. So I believe that it will help you to ease up your uh, work. I mean, fault finding and diagnosis. Thank you very much for being with me. We'll meet again another day with another video.